So good morning everyone. As you all know that we have started with our leveling chapter in surveying 1. The next part which is related to leveling is your trigonometric leveling. Okay, so in trigonometric leveling basically what we find out the difference of elevation between the two stations as well as with the help of some observed angle, vertical angle as well as the distance. So basically in trigonometric leveling you have to find out the elevation by finding out some vertical angles and the known distance with the help of this only. So the vertical angles are measured by means of theodolite. So basically you are not using any dumpy level or your auto level instrument for this type of measurement, because with the help of dumpy level and auto level you cannot find out the vertical angle, but it is only possible with the help of theodolite. So for that you have to use the theodolite for this. Okay. Next one is the horizontal distance by instrument. So we can also find out the horizontal distance with the help of your chain or tape. So these two things are required. Based on that we apply some trigonometric rules and we find out the difference of elevation of the station as well as vertical distance as well as the distance. The relative height are calculated using trigonometric function. So as I've told you, the heights are calculated by using trigonometric function. Okay. Note, if the distance between the instrument station and the object is small, the correction of the earth curvature is not required. So if you are doing it for a very small area, you don't need to consider your curvature effect and refraction effect. Okay. Now in this we have basically three methods by which you can calculate what your height. So one is the case in which the base of the object is accessible. So that means you can easily reach the base. That means this much. This type of leveling, you can see that from here to here you can easily reach over here. So the base is easily accessible. Second one, when the base of the object is inaccessible, the instrument station is in the vertical plane of the elevated object, so you cannot reach the base because it is at some height. So let me show the diagram. This case you can see it is at a height, so you are not able to assess, you cannot easily assess over there. So that is why it is object is inaccessible. The instrument station is in the vertical plane, the station is in vertical plane at an elevated object. Okay, so these are the two cases. The third one is what, the base of the object is inaccessible, the instrument station is not in the vertical plane as the elevated object. So these are the three cases in by which you can perform trigonometric leveling. Out of this, these two are important. This third one is not generally given in your exam, so we are not considering this. We have to study only these two okay, because mostly these two are only asked in your paper. Okay, so we'll start with the first case, that is the base of the object inaccessible. So when the accessible, sorry. So for the base of the object accessible, you can see over here there is a theodolite which has been attached over here at station A. The first reading has been taken on the benchmark. Suppose the reading was BS. Okay. So height will become H1, and then you have this is the height of the element for which you have to find out the height. Okay, this element height is required, that is to be calculated. Okay, so what we have to do with the help of theodolite, we will measure the topmost point of that object, that is, suppose we are considering that it is a point B. Okay, the angle has been measured from the horizontal plane, the angle is given as alpha. Okay, this will be the height. Okay, and by adding your height of instrument you will get this height. Okay, now A is the instrument station. So as you can see that the notations are given over here. A is the instrument station, B is the point to be observed, H is the elevation of B from the instrument axis. So it is from the instrument axis. Now the horizontal distance between A and the object base is this distance is given by D. H1 is the height of instrument, BS is the shaft reading kept on the benchmark, alpha is the angle of elevation. Now if you want to find out the RL of B, what you have to do, we have to find out the benchmark. Benchmark RL is already given, so benchmark RL plus BS, that will give you the height of instrument, plus H, that will give you the height of your B, RL of B. So RL of benchmark plus BS plus H, that will give you your RL of B. Okay, so that was required which we need to calculate it. Okay, so now this can be H over here, RL of benchmark is given, backside reading will be given, but we don't have the height. So height can be evaluated by using trigonometric rule. That is what, if you apply what, tan alpha. If you apply the tan alpha in this particular triangle, in this triangle, what you will get, perpendicular upon base. So perpendicular is h and base is your d. So h will be equals to what? D tan alpha. Okay. So please spare with my handwriting. Actually, I am writing it with the mouse, so I am not able to write it properly. So basically, h becomes what d tan alpha. So by h can be replaced by what? D tan alpha over here. Okay. Now we can easily measure, because it is accessible. We can measure the distance. Okay. We have already got the angle. So with the help of that, we can easily calculate the RL of benchmark. Okay. Clear. If the distance is large, then correction for curvature and correction for refraction is added. Otherwise, if the distance is not that large, it is very small, we don't need to consider this curvature effect as well as your refraction effect. Okay. Suppose if it is required to be added, what will be added? RL of benchmark plus BS plus D tan alpha plus 0.0673 D square. Okay. This will give you the RL of B. Next case is when the object is inaccessible. We cannot reach over there. The instrument station is in the vertical plane as the elevated object. Okay. So there are two cases in this: when the instrument axes are at the same level. Okay. When the instrument axes are at the same level, when the instrument axes are at different level. Okay. So we'll see one by one. First one is here when the instrument axis is at the same level. So over here you can see that there are two objects which has been provided, two instruments which have been provided. One is at B, one is at point A. What you have to do, we have to take angles from here of to the topmost point. This will be alpha 1, this will be alpha 2. The readings from both the readings of the benchmark are taken from both the points, and because it is at the same level, the instrument axis will be of the same level. Okay, this is the height. So now we will apply the trigonometric rule in this, and we will try to calculate what? The vertical height in this also. See, suppose we need, first we are considering the triangle what? PAP dash. So what is PAP dash? This PA dash P dash. Okay. So in this the distance is what? This is D, this is what? H. So by applying what? Alpha tan, by applying tan alpha 1, it will be what? Perpendicular upon base. Okay. Now we are considering what? So from here h will become what? D tan alpha 1. Okay. So this is first one. Now we will consider the second triangle. Okay. Second triangle. For that it is what? D plus B. Okay. So this will be what? D plus B. And this will be again h only. So tan alpha will be what? Tan alpha 2 equals to what? H by D plus B or B plus D. Same. So h can be replaced by what? B plus D tan alpha 2. Okay. Now we can replace this what? By, we know that this value left hand side is common. So right side will be also same. So D tan alpha 1 equals to what? B plus D tan alpha 2. Okay. Now what we are doing, that we are multiplying this tan alpha 2 into the bracket. So it will be what? B tan alpha 2. Okay. This will be D tan alpha 2. Okay. Now we'll consider D side, D terms on one side and the D term on the other side. So D tan alpha 1 minus what? D tan alpha 2. D we are taking out of the common. D equals to what? D tan alpha 1 minus tan alpha 2. And on the right hand side we are left with what? B tan alpha 2. So from here we can calculate what? The distance. Okay. Distance is given by what? B tan alpha 2 divided by this value. Okay. Now once we get D value, we can easily calculate what? The value of H by putting any one of this angle. We have got what? Suppose we are considering this. H equals to D tan alpha 1. We have got the value of D. D value is what? This value. So we'll write this value into what? Tan alpha 1. That will give you the value of H. Simple. Okay. So in this way you can easily calculate by what? Your horizontal distance as well as the height of the object. Okay. So in this, what you have to do, you will have to find out the angles. That can be done with the help of theodolite. B is required. Again, it is the horizontal distance that you can easily calculate. Okay, we cannot go over there, so we need to require d also. So we are calculating d. Tan alpha 1 can be calculated, alpha 1 can be calculated, alpha 2 can be calculated, alpha 2 can be calculated. B is also calculatable because these 2 point distance we can easily calculate, because this is accessible, this is not accessible. Okay, with the help of this we can also calculate the value of h. Once we have got the value of h, once we have got the value of d, we will put the value of d in these two equation, in one equation or two equation. You will easily get your answer, okay, for height. Okay, now the next one, when the instrument axes are at different level. So when the instrument axis is never to the axis never to the object is lower. So suppose you can see that this is the condition for the second case. What is happening? There are 2 points from where we are measuring this pole at point P. The angle which has been measured from this point is called as alpha 1. The angle which has been measured from this point is called as alpha 2. From here to here the distance is capital D, and from here to here the distance is small b. Okay. Similar, same thing we have to do, we have done in the previous part. We need to apply one more thing. We are considering that from here the height from this axis is h1 and from this axis it is h2. Okay, the benchmark is given. We are taking all the reading on the benchmark from this point. We are also taking a reading on benchmark from here, this side. We are also taking a reading on benchmark. Okay, now we'll consider the triangles for the first one, P A P dash, P A P dash. We can get that it is d tan alpha 1 by applying trigonometric rule. Similarly for this one, this will be what, b plus d tan alpha 2. This is similar to what we have done. Okay, but in this case the values are different on the left hand side. It is h1 and h2. These are not same. Previously it was same, but this time it is not same. Okay, now hd is the difference between the two height. So as you can see that this level is not the same, so there will be some difference. So h1 minus h2 is nothing but hd. So hd is what, h1 minus h2, whichever is greater, that we need to consider the first, h1 minus h2. Okay, now we will apply this h1 minus h2. We'll put the value of h1 and h2 in this form, d tan alpha 1 minus b plus d tan alpha 2. Okay, now we will consider, we will multiply this tan alpha 2 inside, so it will be b tan alpha 2 and minus d tan alpha 2. Now what, we'll consider d terms on one side. Okay, so we'll d tan alpha 1 minus d tan alpha 2, d taking common, tan alpha 1 minus tan alpha 2 minus d tan alpha 2. Okay, we need to find out the value of hd. Okay, so what we have to do, that we are taking this on the right hand, on your left hand side, it will become positive d tan alpha 1. Okay, this is d tan alpha 2. Okay, the value of what is this required? We require the value of d. So what we have to do, we have to take d on the right hand side and other terms on the left hand side. So this will be divided. So h will be d equals to what, hd plus b tan alpha 2 minus tan alpha 1 minus tan alpha 2. Okay, so in this way, once you have got the height, once you have got the distance, by putting this in this equation you can get the height h1. By putting this in this equation, the value of d in this equation, you can get the value of h1 and h2. So in this way you have to perform your trigonometric leveling with the help of what, here we are considering only the angles. We are finding the angles, as well as we have got only this distance, the distance between these 2 points. Okay, now by applying trigonometric rule, what we are doing, we are trying to find out the height of this particular point. Okay, we are calculating the distance as well as the height. Okay, so this is the first case. In the second condition, now the instrument axis of the object is higher. As you can see that the instrument axis is higher. In this case the instrument axis was lower, it was below. In this it is higher. So it is also done in the same manner. Okay, applying what, same trigonometric rule, PA P dash d tan alpha 1, PA P dash P B P dash, this will be b plus d tan alpha 2. Difference against, in this h2 is bigger, h1 is smaller, so h2 minus h1. Okay, now applying what, by putting this value. Okay, then opening this tan alpha 2, taking d as common, tan alpha 2 minus tan alpha 1, this will be b tan alpha 2. Now taking this value on the left hand side, this will be hd minus b tan alpha 2 into d tan alpha 2 minus alpha 1. We need to find out only d, so we'll put this value on the downside. It will be what, b tan alpha 2 minus your HD into tan alpha 1 minus tan alpha 2. Once you got D, you can put it in the above anyone for the equation, and you can easily calculate what is the value. Okay, so in this way you need to find out the height as well as the vertical as well as the horizontal distance by using these conditions and by using this formulas. Okay, so some small short numericals are asked on this type of question that I will show you in the next class. Okay, the numerical part of this particular questions. Okay, thank you so much.